Good morning, CP Calculus class. This is Miss G. It is Tuesday, March 31st, and we are continuing our work on section 5.3, exponential and logarithmic integrals. Today, we're going to focus on logarithmic integrals. I hope yesterday's exponential ones went fine. I didn't get any questions that I saw, so we'll just move to logarithmic integrals. All right, so again, we're going to recall something from chapter 4, section 4.5, that if y is equal to the natural log of x, then y prime is equal to 1 over x. Remember that? If y is ln x, y prime is 1 over x, which means if we go backwards and integrate 1 over x dx, we should get back the natural log of x. Now, I put absolute values around the x because you can't take the natural log of a negative number. Can't take the natural log of 0 either, but the absolute values is to protect the x from being negative. So the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. So there really are two rules. That's one of them. Let me summarize the rules for today. The one we just saw, the integral of 1 over x, that's an x right there, that smudge. The integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. This can also look like the integral of x to the negative 1 dx because 1 over x is the same as x to the negative 1 dx, which is going to have the same result. It's going to equal the natural log of the absolute value of x plus c. And if we end up doing a u du substitution in our problem and we end up with the integral of 1 over u du, or u to the negative 1 du, then that result is equal to the natural log of the absolute value of u plus c. And then in those problems at the end, we take out the u and we substitute back in with x's. All right, let's see how this works. Here's our example. The integral of 4 over x dx. So that's the same as the integral of 4 times 1 over x dx. If you multiply this, you'd get that back. Now 4 is just a coefficient, so we can pull it in front of the integral. And now we're just integrating 1 over x dx, which we just learned that the integral of 1 over x dx is the natural log of the absolute value of x plus c, and then we bring our 4 down. Now, just want to make a little note. What if you wrote 4 over x as 4x to the negative 1? Because 4 times 1 over x is 4 times x to the negative 1. And we tried to integrate it with our power rule where we add 1 to the exponent, then we would get negative 1 plus 1, so that would be x to the 0, and we would divide the coefficient by our new exponent, but our new exponent is 0, and you can't divide by 0. So, using this power rule integration technique, when the exponent is negative 1, which is the same as 1 over x, it doesn't work. See? No, does not work. So I just wrote that in case you wrote 1 over x as x to the negative 1, you cannot integrate it like this. You have to integrate it by our rule. The integral of x to the negative 1 dx is the natural log of the absolute value of x plus c. But I didn't want you to fall into that trap. So don't do that, but we'll do this. So we'll continue with a few more examples like this. All right, our next example is the integral of 3 over 3x plus 1 dx. Now in these problems, we have to do a u du substitution because it's not just 1 over x, it's the 3 over 3x plus 1. And in these problems, like yesterday, our u turned out to be the exponent on e to the x, that whatever the exponent was, if it wasn't an x, that was our u. Today, our u is going to end up being our denominator. The denominator is inside the quotient, the function within the function. So u is 3x plus 1. The derivative of that is 3dx. The perfect problem because 3dx is the rest of our problem. So we don't have to pull the 3 in front because it shows up in our du. So now we have the integral of 1 over u. Our u is 3x plus 1. The du could go in the numerator, but I like it on the side, and then I just replace the numerator by a 1. So now we're integrating 1 over u du, which we just learned today was the natural log of the absolute value of u plus c. And then again, we have to put our x's back in. So the answer is going to be the natural log of the absolute value of 3x plus 1 plus c. Done. All right, let's do another one. All right, so here we have the integral of 1 over 2x minus 1 dx. Again, we pick our denominator, which is our function within the function, as our u. So u is 2x minus 1. Our derivative of that is just 2 dx. We go back to our problem, but there is no 2 in the numerator. So we picked up a 2 we don't want because it's not in the numerator. So I'm sure you know what to do with this by now because we've been doing it with all our other types of integrals. We don't want the 2. We multiply by the reciprocal of the 2 as a 1/2 in front of the integral. And so we have 1/2 times the integral of 1 over u, our u being 2x minus 1, du. And the integral of 1 over u du is the natural log of the absolute value of u plus c, and we bring down the 1/2, and then we substitute back in the 2x minus 1 for our u. So we get 1/2 times the natural log of the absolute value of 2x minus 1 plus c. I think I have one more of these. Let's see. Yes. Okay. This one, the integral of 6x over x squared plus 1 dx. All right, so our u is our denominator, x squared plus 1. The derivative of that is going to be 2x dx. And x dx is in our problem. That's a good thing. But the 2 is not. We do not want the 2. But we do have a 6 we can't get rid of because it's in the problem. So we're going to get rid of the 2 by putting our 1/2 out front of the integral, and we're going to move the 6 in front of the integral because that can't go anywhere because it's already in the problem. And then our substitution becomes 1 over u du. And 1/2 times 6 gives us 3. So we get 3 times the integral of 1 over u du. And the integral of 1 over u du is the natural log of the absolute value of u plus c, and we bring our 3 down. All right, so then we take the u out, put the x's back in. We get 3 times the natural log of the absolute value of x squared plus 1 plus c. Now that's a perfectly good answer, but really, we don't need these absolute value signs because x squared plus 1, we never have to worry about that being negative because when you square something, it's positive, and if I add 1 to something that's positive, it's still positive. So you don't need the absolute values in this problem because there's no danger that x squared plus 1 could ever be negative no matter what x you put in. So the best answer would be 3 times the natural log of x squared plus 1 in quantity, using parentheses there, plus c. But if you put the absolute values, I wouldn't mark it wrong. Okay, that's our answer. Okay, I hope you followed this. And so I have a few problems. They are in section 5.3, page 336. Numbers 15, 17, 19, 21, and 23. If you have any questions or need any of those done out, email me. And don't forget to save your work because pretty soon I'm going to have you take pictures of them, put them in a direct message to me, group me, and then send them to me so you can have some credit for all this work you've been doing. All right? So we're not going to do that yet. I'll put out a group me message on that maybe tomorrow. And you can start getting your assignments ready. I'll make a list of all the ones we've done, and then you'll know what to go look for, okay? I hope you have a great day, and I really miss you guys. All right, bye.